So we are going to see the data warehouse concept, why and what are the different ways that we are going to store the data, and why, basically what is the use of storing the data, why we use the data, that's the thing. Okay, that all we are going to discuss. So normally, so there may be different things. Previously, like there is a company. First let's go step by step at the beginning. So what was the process at the beginning? The company has 3 branches: branch A, branch B, and branch C. So branch A using some flat files, it always stores data in some text files. It is flat files, it is nothing but a text files or .csv files. And company BB, what branch B, what happens? It stores the data in the Oracle database, Oracle DB, and branch C stores the data in SQL Server. Okay, this is the thing that I have. Now let's say there is a scenario where if the company wants to see total all sales for all 3 databases. Let's say the company A wants to see total sales for branch A, branch B, branch C. So what it needs to do? It needs to get the data from a flat file, it needs to get the sales from this Oracle database, and it needs to get the data from SQL Server. So here there is like you need to what, after getting all the sales, then you need to, because it's from 3 different databases, right? So you should have access to 3 databases. There is some manager here. Okay, manager wants to get, he wants to compare all the sales between all the 3 databases. Then what he will be doing? He will get details from here, he will get details from here, he will get details from here. And the flat file he got. Flat file means basically he may get in some text, or he may take some printout. Done. After taking the printout, he should manually merge the data from this one, ODBC and SQL Server. You need to merge the data, and you need to do a lot of stuff here. Okay. So if you want to, because each year the data is stored in different formats, it will be hard for you to compare or to manage. And see this flat file, right? So since it is a flat file, so if the flat file gets damaged, so how you are going to do? You can't even, if you have used data in the flat file, you can't even search that. Like there are many disadvantages with each and everything. Okay. So for this purpose, what they do normally, they make a normalized tables. Okay, they will have the OLTP system. It is a online transactional processing. O means online, L means OL means online, T means transactional, P means processing. Okay, so here what they are going to do, they are going to update, they are going to centralize all the 3 databases into one database. Okay, flat file, Oracle and SQL Server, all the data in all the 3 databases are going to update in the OLTP, and at the same time the manager who is having access, now you will directly access this OLTP for this for the further scenario. The OLTP will have the normalized tables. Okay, OLTP will have the normalized table. Normalized tables is nothing simple. I can explain simply. Let's say I got a table where EMP ID, EMP name, EMP address. Let's say I got this, and I got one more called EMP salary, or let's say I will not go with the EMP. I'll just go EMP ID, EMP name, and I can go with like EMP department. Okay, EMP department something. So I got EMP department is divided into 2 parts. I can name it as EMP department ID and EMP department name. So these 2 tables are in a single table. So this all 4 columns are there in a single table. Now if I normalize this, there are many ways of, there are many types. First normalization, second normalization, third normalization, fourth, fifth, and you got buoyancy code normalization, like that. Okay, when you go, you can break the table in many ways, but simply saying I can break the tables in 2 ways. I can break it as EMP ID, EMP name, and EMP department ID as one table. Another table is a department ID and department name as another table. Okay, and I'll make relation, this EMP department ID will be the foreign key relationship to the department ID table. So breaking the table is called the normalization. The same way we normalize the tables here, whatever tables we got, this, since it is a flat file, okay, and flat file may store, we may have data for multiple things in a single flat file. Or let's say this branch A is having employer, so we have one flat file which stores the details of the employees, and sales. But there is one more flat file which shows the total sales. It may be flat file or it may be Excel, anything. So now what they do, they normalize the data, and what they create a tables. They normalize the tables. This OLTP will have the normalized tables. So when you are going to say normalize is that whenever the tables are satisfying the third normal form, okay, when the tables, remember up to here, when the tables are satisfying the third normal form, then the tables are called normalized tables. Minimum the tables should satisfy the third normal form. So when you are satisfying the third normal form, nothing but you will have the at the end of the third normal form, you will have all the foreign key relationships, and the tables will be broken, and you will have the like the referential integrity, that all relationship you will have. That is nothing but the third normalization. You can go ahead and you can search in Google and you can study a lot. So you will getting the normalized table. So here what happens, and for loading the data from flat file and Oracle and SQL Server, you use some ETL tool, extract transform load tool, to load the data, because in the flat file the data may be stored in different format. In the Oracle the data may be stored in different format. In the SQL Server the data may be stored in different format, and this branch C may be in some other country, branch B in some other country, and branch A in some other country. So each country has its own way, right? So let's say in India the time format is different and the US time format is different. So if you want to make both the time format, so this is a centralized database. What you are going to do, you are going to convert all the time formats into some standard format, and you are going to load it into the normalized tables. How you are going to load? By using a ETL tool. So Microsoft has one ETL tool called SSIS. That is a tool that you use for loading the data from different things. And here one more thing, since the flat file, what you will be doing, so you load into the normalized data, and based on the requirements you will update the data. See, in the flat file the users or the sales means every minute or every second they will insert the data into the flat file, right? So in this scenario what happens, whenever they insert, you might write process to run every 30 seconds or every 1 minute, load the newly inserted records from the flat file and update it into the normalized table, that is the OLTP. The same thing you can do with the ODBC and SQL Server. What are the latest records they might have inserted, that all records you might keep in the normalized tables. Okay, that is the one thing you are going to do. That is the how you are going to load the data by using SSIS. So we are good. You loaded the data into the OLTP and normalized tables. So the next scenario comes. Okay, you loaded the data into the OLTP, and OLTP is, you will update the OLTP every 1 minute. Or okay, let's leave it here. Yeah, every 1 minute you will be updating. Done. And after this, what you are going to do, let's say you will be adding the data day to day, daily you will be adding. Every day, let's say that there is 1 million records added to this one. Every day you will be adding 1 million records to the OLTP. So by the end of the year you will have 360 million records. So 365 or 366 million records by end of the day. So you might observe one thing, when you have a table, if you have 10 records in the table, and if you write select star from table name where ID equal to 1, if there are 10 records, you given some ID equal to some 10 or 11, anything. If there are 10 records, when you give this search operation, or if you want to update table set name equal to something where ID equal to 11, or even you can use delete also, delete from okay table where give me a minute. Hi Durga.
Sorry, Buster, my system suddenly getting restarted.
Okay.
So I'm not in the call now.
Okay.
So can I till it get connected? Can I be in the call?
Okay, you can be in the call.
Okay.
Okay, so this is a scenario. So what we are going to do here, when you have 10 records, and when you run the update command, or when you run the select command, or when you run the delete command, if you have 10 records, every command, all the commands runs fast, because you are having only 10 records, right? So if you run select star from table name equal to, let's say 1 2 3 4 5 6 7 8 10 11, so we got this many records, 10 records we got, because we don't have 9, so we got 10 records. If we want to delete 10, so what the system does, system searches each and every record. Okay, 10, it found 10, so it will delete. If you want to update, within few searches it will found the record 10 and it will update. Okay, if you want to delete, within few searches it will found and it can delete. Let's say there are some 10 million records. Let's say for finding the record out of 10, it may take only 0.001 second. For finding a record out of this 10 records, it may take only 0.001 second. But to find a record out of some 100 million, then it may take even in minutes. Sometimes it may take in 1 minute, sometimes it may take even like 2 to 3 minutes. Depends on the scenario, based on the index and that all stuff. Okay, so it may take more than that. Because of that, what you are going to do, and here one more thing, you got this 365 million records, and the people, you might update, you might delete, or you may do only few records. Like if you go to the Walmart, every day there are some thousands of transactions. What is suppose you in the Walmart, there is one transaction added today. Okay, this is a Walmart. I am having multiple branches. This is my data. So today on, let's say on Jan 2013, okay, Jan 1st 2013, they added one transaction into the table. Okay, they added one transaction into the table, that is a 13, year, date and month. They added one transaction, done. So what is the frequency of again modifying the transaction? Let's say you did one transaction, the transaction date is on this day, done. And what is the chances of you going and changing? So the total sales for the transaction may be $300. So you bought one bed and it is a $300, and after that, the Walmart, you got the return policy of 90 days. Then what you are going to do, out of 90 days, you are going to have this transaction in the date. You are going to use the transaction. Let's say let's say April, there is one more transaction call on April. There is one more transaction, April 01/13. Now on this day, the transactions which are inserted prior 90 days prior to this date, you are not at all going to use the transaction. There is no need of you, because you are not at all going to update the transaction, you are not at all going to delete, because already 90 days period is done. So once the 90 days period is done, there is no need for, there is no use for you to return the bed, right? Even though you return, it is not valid, because the time has been expired. So there is, so you can't, there is no chance for you to update this transaction again and again. So in that scenario, the same way here, so you inserted 365 million records per 1 year. Out of 365 million records, let's say only 100 million records may be updated. Only 100 million records are useful. The people, they might update the 100 million records, they might delete, or they might insert only the 100 million records. So rest 265 million records are wasted, means they are useful, but they are not used now at this level. For update, insert, delete, they are not used here. So if we remove the 265 million records, and if we keep only 100 million records, because the total count is reduced, then the users, whoever wants to update or delete, because when there are 365 million records, it takes some time, but there are 100 million records, because you have reduced the count, right? So whenever if you want to update or delete, it will take less time. That is the one more thing. So in this scenario, you need to remove the unwanted records. That is the one case. Other case is that, so the people, what they are going to do, you will be loading the data into the OLTP, right? You will update the data from all the 3 sources. You will update, you delete, you will update, you will delete, you will you will insert, and all the stuff you will be doing to the OLTP. During the updation or deletion or truncation, let's say my manager writes some query. Okay, my manager writes some query which pulls some records. Let's say there is a table A. On the table A, my manager writes some query to pull the data, okay, and the query takes 10 minutes. During that process, during the execution of that query process, no one can update the table A, because it will be logged. The table A will be logged. So since the table A will be logged, because he is doing a select query, so during that select query, the other people cannot access that, cannot update it. Because of that, what happens? Whoever person wants to update the table, he need to wait for 10 minutes. Then, because if someone waits for 10 minutes, the other people also will be waiting. Okay, so that is the one more reason. So if my manager is there, so there is a one more thing. So instead of my manager accessing the database A directly, you can take the copy of the database and store it in somewhere location, and the manager, he should access that database instead of accessing directly the original database. Like you can make a copy. So this is a one other scenario that you can do. If your manager, like we discussed two scenarios. The first scenario is that if there are millions of records, if you want to update or delete, it takes more time. So in that scenario, you can remove all the unwanted records and store it in some other location. That is the one scenario. Second scenario is that my data, so is on a single table. The users, or you might be loading the data from all the three sources into the table, and during that time, if someone is updating or someone is doing some select statement on the table, okay, or the table which you want to update, if someone is running select query which takes 10 minutes, and then what happens? You can't update it because he is doing select query, so you need to wait for 10 minutes to update the table. So because of that, and there may be like 15 to 20 managers, each manager runs this way, then all the query processes, everything, the tables may be deadlocked and the process may be slow, and you will be facing many scenarios. So for this purpose, there is one more concept that a SQL server has introduced, is that, so you will be loading the data into OLTP, right? So what you will be doing, whatever the data is there in the OLTP, let's say the OLTP has 10 years data. Now you load all the 10 years data into one data warehouse. Okay, you load all the 10 years data into in the data warehouse. There is two types of data warehouse. One is the OLAP. You will call it as data warehouse means nothing but OLAP. You will call it as ROLAP and MOLAP. There are two types. First, we will be discussing about the ROLAP. Okay, this is the ROLAP. Now what you do, you will move all the 10 years data into the ROLAP, and since you move all the 10 years data into the ROLAP, so now whatever the data you need here, let's say you need only 2 years data, so you will keep only 2 years. For plus point, you will keep 3 years data, and you will move, because already the 10 years data is stored in the ROLAP, right? Done. So there is no need for you to store the other data. So just you will delete all the 7 years data from this. You move all the data here. Once you copied all the data into the ROLAP, you will just delete the unwanted data from the OLTP, and you will just have only the 3 years data. So in the next year, you will delete the old year data. So let's say that it is 2014. So you may have the data from 2011, let's say 2012 or 2013, 2014 you add it. So when the next year data comes, you will delete the 2011 data. When again 2016 comes, you will delete the 2012 data, like that. Okay, you will be keeping only 3 to 4 years data into the OLTP. And now because there is less data, the users, whoever is updating, it will be faster. Okay, it will be faster. And my manager who wants to run the queries, so instead of running the queries again OLTP, he will run the queries on the ROLAP, because since he runs the queries on the ROLAP, so there will be no other person, because the users, they will be updating this OLTP, and on the ROLAP the people will not be updating, right? And the people will not be updating much on the ROLAP. So because of that, there will be no deadlocks, and your manager or someone, whoever wants to pull the data, you will directly pull the data from ROLAP, and it will be faster also. Previously on the single database, the users, the managers, all will run the queries on the same database. Because of that, the performance will be reduced. But now the managers has their own database and the users, they add their own database, OLTP. So because of that, the process and the usage has been breaked into two parts. managers or the high level people, they will be accessing the data warehouse. The users who on day to day transaction, they will be updating in the OLTP. So because of this, since you had break the usage, so now the whoever is accessing, it will be faster. And now one more thing, okay, you loaded up data up to today, you loaded up to data September 2nd 2014. Now so this data ROLAP will have the data up to 9/2/2014. Tomorrow, by tomorrow, if there is like 500 million record, 500,000 record, 500,000 record, if 500,000 records has been inserted into the OLTP, and how you are going to load the data into the data warehouse or OLAP. So we have seen the incremental, right? So whatever the data has been added here, so you will be loading nightly, because you should remember in each and every company during the daytime there will be much load on the company servers and all the databases, because many people will try to access, but after during the night time there will be very less load on the server. So the people whoever wants to do any operations or anything, they will run this process during the night time. Whatever the data has been added to the OLTP, the entire data the new data will be merged with the, or you will write some SSIS packages to update the ROLAP with the OLTP data. Every nightly you will be doing that. Okay, every nightly you will be doing. So in the ROLAP, what is the ROLAP? So data warehouse, nothing but OLAP. OLAP is divided into two types. One is the ROLAP and another is the MOLAP. What is the ROLAP? ROLAP is nothing but, since you load the data into this data warehouse, so OLTP is the normalized table. So you will do little bit denormalization again. Normalization means breaking one table into multiple tables. That is a normalization. What is a denormalization means? Joining again multiple tables into the, like normalization, you break one table, you may break one table into two tables, or you may break one table into three tables. What is a denormalization? Making the three tables into two tables is nothing but the denormalization. Again combining the tables into the combining the tables to become less tables is nothing but the denormalization. So in the you will do the denormalization. The concept of denormalization is nothing but you will call it as facts and dimension tables. Facts and dimension tables. So here the facts table will have the facts data, dimension table will have the dimension data. Like facts table means, what is the facts table means? It will have the facts data means total sales, okay, and like amount, it deals with the amount and quantity. Simple way, it deals with the amount and quantity. Facts tables will have list of, like let's say there is a company, I am having the company ID, okay. So the fact table will be this way. We can create one sample fact table and we can see that. Okay, the fact table will be this way. It will have the company ID, okay, it will have the branch ID, it will have the year, it will have the year ID or something, or it will have the date ID, and next it will have the amount, quantity, tax amount, like this. And next dimensions, you will have the CID, company ID, company ID name, company name and company description. Next branch ID, branch name and branch location, like this. You will have the date ID, you will have the date, year for the date, month or anything. So here you can see these are the dimensions. So the dimensions will have the data which it will have only the description data. You can't see by using this dimension data, okay. These are the dimensions, so I will name it as DDD. These are the dimensions and this is the fact table. CID, branch ID, date ID, it's a date ID and is the amount, quantity and tax amount. So it is a fact table. So by using dimensions data, can you guess anything about the company? What is the total sales of the company? What is the, can you estimate the company profile? No, you can't estimate the company profile just by looking at the dimensions. You can only estimate the company profile based on the total sales, based on the total quantity the company is being produced. Based on that scenario only you are going to estimate. So the fact table will have the only the IDs of the dimension table. The fact table, see, branch ID, year ID, it will join with this date ID, that is it. So, the fact table will have the only the IDs of the dimension table, and it will have the fact data. This is called the fact data, amount, quantity, total amount, this is called the fact data. Like year, branch ID, CID, it all are called the dimensions. It is called the primary keys matching to this company IDs. Primary keys matching to the company. So, this are called the dimension. The table which has a fact data is called the fact table. So, in the fact table, it will have all the IDs pointing to the dimensions. Though this fact table will not have company ID, company name, company description, and next branch ID. It will just have only the IDs, and that IDs will point to the dimension table. Okay, that is a facts and dimensions relationship. And here in the facts and dimensions, there are two types. One is a star schema, and another is a snowflake schema. So the facts tables, the facts and dimension tables are divided into two categories. One is a star schema, and another is a snowflake schema. Okay, what is a star schema? Star schema means we got okay, this one we call it as star schema. We got the fact table, and we got the dimension table as for the company as one dimension, branch we got another dimension, and the date we got another dimension, and this is a fact table. Okay, so fact table is the center, and this fact table, in order to get the information of the anything with the fact table, it will just join with the one table relationship, that's it. So, if you want to get the company this company name and description, just this fact table will join with this company table based on the company ID, it will get the company name and description. So, it will make only one level of join. Okay, let us say this company table, okay, in turn may have one other ID called region ID, where this in which region the company comes. So, there is one other table called region ID, okay, and region description. There is one other table called region ID and region description. So, this region ID will be pointing to the region. The region ID may be east, north central, northeastern, west, or something, south. That all called the regions. I am calling that as a regions. Okay. So, every company ID has one more column called region ID, and that region ID in turn you will join with other table called region ID and region description. So, now if the fact table wants to get the region ID, so what it does? First it joins with the company table, and after that joining with the company table, it gets this region ID, and in turn that region ID will join with another table called region, and then you will get the region description. So, now you are, in order to get single data, in order to get the regional description, you are joining with this one level, and you are again joining with other table. Right? You are joining two levels of joins. That is nothing but the snowflakes. If you want to get a information, you need to join one table, and after that take the region ID, again you will join with other table with that region ID. So, that multi-level joining is nothing but the snowflake schema. If you just have the, instead of this region ID, you will have the region description. You do not have any region table, you will just have the region description. And if that fact table wants to get the region description, so what it does, it just join with the company ID, the company table dimension based on the company ID column. This table has the region description. So, it will just get the region description directly, it will get from this. So, that is nothing but the star schema. Okay. So, always this is one, and you will have the dimensions, you will have the dimensions, you will have the dimensions, you will have the dimensions. This is a fact. So, this level is called the star schema, and if you have the fact, if you have dimensions, dimension, dimension, and dimension, and this dimension in turn will join with other dimension. So, this is nothing but the snowflakes. Okay. So, are you able to get this one? Hello?
Yes.